Hey team, welcome back to my channel. The source code for this video is available on my GitHub account. Follow the arrows, download it, and we can walk through this together. In this video, I will be solving a HackerRank problem that is called binary tree nodes. Notice that I'll be using Microsoft SQL Server to be solving this problem. Before we dive into the source code to this problem solution, I'm going to talk about binary trees. Now, these problems often involve the terms parent-child relationships. So binary trees are hierarchical structures, and each node can have at most 2 children. Now, there's a special case where there is root. Root has no parent, but it can have 0, 1, or 2 children. So we're going to begin with creating a table called BST. Notice a column N and P. Throughout this video, you might hear me call the N field the child and the P the parent. Because remember, this is a parent-child relationship type problem. So you understand the table we have to create. Let's do that. And now we're going to scroll down and look at the data. So the data is just 2 fields. You got child, parent, N, P. You can see here, insert into BST N, P, and here's our sample values. So being a programmer, I kind of wanted to see what this would look like because there's not too many values. And you can quickly see that we have a root node, 15. We have leaves, 1, 3, 5, 7, 8, 10, 12, 14. And these fields in the middle are what's called inner. Very easy to see this. And I'm going to use this diagram to help me solve this problem with our SQL statements. Let's continue. Let us solve this problem. Before I even do anything, let's look how simple this is. Select N, the child node, where P is null. So which one of these P is null? Oh, it's this one right here. So 15 is the root node. Let's execute that. So we're done. So 33% of this problem all done. Now the second part is I want to get all this stuff in the middle. It's called the inner nodes. So once again, I want to get where N is in. Now let's go get a distinct set of P's, of parents, where P is not null. Let's go ahead and execute this SQL statement right here, this subquery. And notice we get the 2, 4, 6. Now look at this right here, 2, 4, 6. And then we're going to go up again, 9, 11, 13. And then notice we get 15. Because 15 is indeed a parent. But now look what I say, and P is not null. So when I do this whole query, I'm only going to get the columns I need. I'm going to get 2, 6, 4, and then I'm going to get 9, 13, 11. These are my inner. So guess what? 66% done. Now leaf nodes, we know one thing. In order to be a leaf node, that child node can never be a parent. So can you find 1 over here as a parent? No, that's because it is indeed a leaf node. And you won't be able to find 3 either. 3 is not on this side. And neither is 10. So all these numbers down here do not have children. So another, once again, a single thing. So here, what are we going to get? Here we're going to get a list of all of our nodes. And I'm saying where N is not in there. I don't want that set. I want that set. And then guess what? At the very bottom, I'm going to use this CTE, and then I'm going to do unions for each one of those, the root node, the inner node, and the leaf node. And there's our output. And that's the solution to this problem. I submitted this code to the problem success.